Okay, so what we're doing right now is we're filling in this flow chart that hopefully will help you on there. So the first thing you need to know is that if we have a right triangle, we don't need to do any of this over here. So if you have a right triangle, we are all good. We don't need to do any of that. We could just do SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, all that wonderful stuff. But if it's an oblique triangle, a non-right triangle, then this is what you're going to have to do. So this is where we have the law of sines and the law of cosines. So what we do here is a non-right triangle, you're going to have some cases. So that's when you have to identify what sides are given and what angles are given to you. So if we have the angle, side, you're good. And if you have the angle, side, angle, or you're given two angles and a side, then you're good to go. The order does matter in which you're given to them. And so if they're in this order where they give you two angles in a row and then the side follows, or if you're given an angle, then a side, then an angle, then you do the law of sines and you go directly here. So once you have that, you go straight to here and you apply depending on what sides and what angles, you fill that in and then you solve the triangle. If you are given the case that we talked just recently about, the ambiguous case, that is when we do the side angle. This is the one where we have lots of conditions. I am going to like take that from blue and put it to red. This is the case that we have to know the different cases that are going to be there, and that's the ambiguous case. You are still going to do the law, you are still doing the law of sines here. You're still going to do it as well as there, but now you have to decide first before you apply the law of sines whether there's one triangle, no triangles, or two triangles. So you have to identify that on there. You also have to identify whether the angle that's given to you is acute or whether it's obtuse. So we're going to go into that case right there. And then we'll go over on the side at the end about the law of cosines on there. And that's what we're going to do the next case after this. But we'll fill that out with the cases anyway. And if you look, the law of cosines, it looks kind of scary, but it really isn't once we explain it. So back to the ambiguous case. I know, we have to do it. So the two possibilities after you identify that it is given to you two sides and an angle right after it. So a side and then a side right next to it and then the angle. Remember that the side and the angle has to be special. So that means that it has to give you an angle. So angle, and it has to be the side opposite that angle. If they don't give you an angle on the side opposite of that angle, then it's not the ambiguous case. So they're going to give one of the sides has to be opposite the angle that's given. If that's the case, then we have this case right there, and we have to do the ambiguous case. Now, once we're done with that, you have to identify what kind of angle is it. So is it an acute angle? So less than 90, or is it an obtuse angle? And that is going to be greater than 90. So if they're giving you an acute angle or an obtuse angle, then you go in different directions. If it's an obtuse angle, we only have two things that it could be, and that is easy to understand. And I'm going to show you this again over here. So if we're given this side, so let's say that the angle is going to be let's say 135, and I have this. So this here is an obtuse angle, and then this is the side that's given to us, and so this here is the opposite side. So if I look at this side has to reach the third side right over here in order to form a triangle. The problem is that in this case here, the side opposite is 10, the side adjacent is 15. There's no way that this one here is going to reach this one here on that side. So anything between 0 and 15, it's not going to reach it. So what happens if I actually have 15 there? If I have 15, it is still not going to reach it because that's the length of the opposite side. So see, notice how it does not form a triangle on there. So that means that any length greater than 15, whether it's even 17, oh, I put 117, even if it's, oops, sorry, I filled in the wrong one. Even if the opposite side is 17 greater than the adjacent side, it will still reach the opposite side. So anything longer than 15 is going to reach it, and that's going to be all the way over here. So that's how we know that is. So now going back to fill in our chart here, if it's an obtuse angle, if the opposite side, there we go, yeah. So if the opposite side is less than, smaller than the adjacent side, then we know we have no solution because there is not a triangle. It doesn't reach it. Now, if the opposite side is greater than, not equal to, greater than, because it cannot be equal to the the adjacent side. So now if the opposite side is bigger than the adjacent side, then we have one triangle, and therefore it's going to be one solution for everything. So it's one angle, one side, one everything for all. So it's only one triangle. So one triangle. Very good. Okay, so that's the obtuse case. Now let's go to the acute case. So for the acute case, there's a couple of things that we need to know. So for the acute case, that's a little bit more difficult, and we have to go back and look and see what's happening. So from the acute case, so now let's go back and let's change this to, let's say, 65 again. So here is an acute case. And so now we know that there's quite a few things that could happen. So here the adjacent side is still 15. So if I'm looking at this, this could go anywhere. And so let's start with what happens if the opposite side, and we're not really comparing this because we want to know whether the opposite side is going to reach the third side. So in order for it to actually reach the third side, we have to know the shortest distance from this vertex to the opposite side. In that case, that's when we drop the altitude, or what we call the height, to form a right triangle. So when we do that, this here is the shortest distance. It forms a right angle. So I need to know that one. And so I use, to find that height, the adjacent sine of the angle that's given. It turns out when I put the adjacent side 15 into the sine of the angle 65, it's going to give me that this length right here, the height is 13.59. So if this side, the opposite side, is smaller, let's say 10, smaller than the height, then this one here is, and this is the height, it's never going to reach the third side, and so there is no triangle. So let's go back and write that on there. So the thing that we need to do before we do all this is we need to find the height h, and that is going to be giving us by the adjacent side multiplied by the sine of the angle. Okay, so when we do that, we find out the adjacent side, then we do the comparing. If the opposite side is smaller than the height, then there is no solution because there is no triangle. And that's what we just said. Okay, so now what is the next possibility? So let's go back on here and see what the next possibility. What happens if they're equal to each other? What if the opposite side is equal to h? So what if the opposite side is 13.59? So if that is the case, now it's actually reaching. And if I look at this, this here now forms a right triangle. If it forms a right triangle, it forms one triangle. I do not even have to do the law of sines because it is a right triangle, and I could solve it using SOHCAHTOA. So that means that I go back here, and the other one is what happens if the opposite side is equal to my h? And so that is going to be one triangle. So it's going to be one solution, one triangle, and it's going to be using um, SOHCAHTOA. Sorry. Okay, so then what are the two other cases? So let's go back and look and see what the two other cases are going to be. So the two other cases is, well, what happens if it's in between here? So what happens if it's bigger than the hypotenuse, but smaller than the adjacent side. So if it's bigger, that means it has to be greater than 13.6, let's say. So let's say that it is 14, and we hit that enter, and then let's say now that we're going to make this here. Now it's going to fall. See how it doesn't reach the opposite side, but it does touch it here. And then it's bigger than this. It's below it. And then I could also touch it over here. So this is where we're forming two triangles. And let me show you where those two triangles are. So when it touches it right there, then this one here, I am going to put that over here. And I am going to get rid of the height there, and I am going to show you. It forms this obtuse triangle. That's right there. So that's when it touches the third side right there, but it also touches it over here. And so that forms an acute triangle. So those are where your two triangles. So if the opposite side is in between the height and the adjacent side, it's going to form two triangles. Okay, hit escape to that. Let's go back and fill that in. So now what happens if the opposite side is bigger? That means that the height is smaller than the opposite side, but the opposite side is still not as big as the adjacent side. So the height is smaller, and then the opposite side is in between the adjacent and the height. Then this one here gives us two triangles, and so therefore we're going to have two solutions of each angle. Well, of the angles that we're finding. So there's only going to be one angle of the ones that are given, but you're going to have two of the sides that are missing and two of the angles that are missing. Okay, now what is the last case? So the last case, let's go back and look at that. So the last case is what if, and let's go back to the height there. What happens if it is bigger than the height, which is all of them are now going to be bigger than the height. But now what if it's bigger than the adjacent side? So what if the opposite side is bigger than the adjacent? So what if it's bigger than 17, not 117, let's say just 17. Or let's make it 20, just so that we could see. No, that went to 120. Okay, so what if I look at that? So I am going to get rid of this, and now I'm going to be able to form a triangle. Well, here, anything between the height and this one here, it's not going to form a triangle. It's going to have to go all the way over here, but I can't go all the way over here because this angle is found here. I can't go past it because it has to include this angle. So what we do is we go the other way. And so we swing this way and it touches it over there. So that's where we're forming the triangle there. And so now it just forms one triangle because we can't go on this side. We could only go on that side. And so if the opposite side is bigger than the adjacent side, then it's going to be one triangle. And let's fill that in. So if we get that the opposite side is going to be bigger than the adjacent side, and obviously it's going to have to be bigger than the height, then we get one solution, one triangle. Okay, so I think that covers everything with the ambiguous case, but now we want to go back to the law of cosines. So these are the three different cases here. These are the side angle, the angle side, and the angle side angle gives you all the law of sines. The law of cosines, which we'll be talking about, is going to then give you, I'll do that in green. That one's going to give you if you have the side, angle, side. So if you're given one side, the angle in between it, and the other side, it's going to be the law of cosines. And if we do the side, angle, that's going to be the other part. And then if you look at that, this is the law of sines, and this is the law of cosines. Okay, very good.